Welcome back to Nautical Depths, your favorite place to learn about cutting-edge research in underwater world and everything below the oceans. Today we're diving into the fascinating world of archaeology and unearthing a story that goes back thousands of years, a story scribed in the skeletal remains of a prehistoric human found in an underwater cave off the Caribbean coast of Mexico. Our journey begins with an enigmatic discovery by archaeologists Octavio del Rio and Peter Broger. This experienced duo is known for their scientific adventures, which often involve unraveling the secrets of the prehistoric world. The cave they investigated this time was a unique one. It's been submerged for about 8,000 years, its secrets lying untouched, preserved by the icy silence of the underwater world. In this cave, within its ancient sediment layers, lay the remains of a once living, breathing human, a skull fractured by time, and a skeleton partially concealed beneath the sediments. The depth at which these remains were found strongly indicates their antiquity, placing them in the prehistoric era. But who was this individual? Could it be a long-lost ancestor of ours? What were their dreams, fears, and aspirations? How did they live? And what might have led to their final rest in this underwater grave? The implications of this finding are immense. These skeletal remains offer us valuable insights into our prehistoric past. This region, renowned for its cenotes sinkhole caves, has previously yielded some of the oldest human remains in North America. Can you imagine that? Our earliest ancestors making their home in these now submerged caves, living out their lives in a world unimaginably different from ours. The significance of cenotes as archaeological hotspots has been further cemented by this discovery. What other secrets do these underwater caves hold? How many more such remains are waiting to be found? And what might they reveal about our human story? Another prehistoric human skeleton has been discovered in a submerged cave in Mexico. This finding contributes to the body of knowledge concerning human habitation in the Americas, providing further evidence to support the theory that early humans migrated across the Bering Strait and down the American continent. This underwater cavern is found in the Yucatan Peninsula, renowned for its broad network of underwater caves, or cenotes, that were venerated by the ancient Maya. These cenotes, due to their constant water levels, have provided the perfect conditions for the preservation of historical artifacts. Over time, these caves have yielded a myriad of archaeological treasures, and this latest find is perhaps the most consequential to date. The discovered skeleton, affectionately named Naya in a nod to the Greek term for water nymph, has been meticulously aged through the application of radiocarbon dating methods. Preliminary estimates suggest that the skeleton is over 13,000 years old, placing its origin in the late Pleistocene epoch. This finding represents one of the earliest known instances of human habitation in the Americas. Adding to the excitement of this discovery, scientists were successful in extracting DNA from these skeletal remains, opening up the possibility of gaining deeper insights into the genetic lineage of the early settlers of the continent. The skeleton of Naya was found alongside various artifacts, including primitive stone tools and remnants of extinct fauna. The assortment and positioning of these items suggest that Naya may have accidentally fallen into the cavern and was unable to navigate her way out. This unfortunate incident, while tragic, has bestowed upon modern-day scientists a treasure trove of information offering a unique glimpse into the life and environment of the first Americans. Beyond the scientific community, the discovery of Naya has sparked widespread interest among historians, anthropologists, and the public alike. It has been hailed as a significant contribution to the understanding of early human migration patterns and adaptation strategies. It's anticipated that the continuous analysis of the skeleton and its associated artifacts will reveal more about the lifestyle, dietary habits, and possibly even the social and cultural practices of our prehistoric ancestors. Furthermore, the extracted DNA holds enormous potential for comparing the genetic traits of ancient and contemporary indigenous populations, potentially unveiling new layers of evolutionary history. As we journey into our history, the encroachment of modern problems becomes apparent. The high-speed Maya train project in Mexico, aimed to stimulate tourism and the economy, presents a direct threat to potentially significant archaeological sites. The dilemma: Do we progress into the future at the expense of our past? Preservation is a formidable challenge. On discovery of his archaeological find, Octavio del Rio alerted the National Institute of Anthropology and History. Yet concerns loom. Will they manage to protect these caves from potential damage due to construction, ensuring their stories aren't lost to future generations? The loss isn't confined to artifacts alone. Each cave tells a unique tale, revealing glimpses into ancient life, climates, ecosystems, and our planet's evolution. As infrastructure projects threaten these sites, we risk losing these invaluable narratives. Del Rio suggests an alternative route along the already developed coastal roadway between Cancun and Tulum. This proposition is fraught with opposition from hotel owners citing cost and traffic issues, proposing instead a route through the forest. But why is underwater archaeology so significant? The reason lies in the nature of the sites themselves. Submerged archaeological sites provide us with a unique snapshot of prehistoric human behavior. The water acts as a protective barrier, preserving these sites in a way that isn't possible on land. The recent discovery of the ancient human skeleton in the underwater cave is a testament to the importance of this field. Yet, exploring underwater archaeological sites isn't without its challenges. It requires specialized diving skills and equipment. It's a world where archaeology meets adventure, where each dive into the watery depths is a journey back in time. One critical aspect of underwater archaeology is the preservation of these fragile sites. With each disturbance, we risk losing precious artifacts and valuable data. The corrosive effects of water, the risk of looting, and the threats posed by construction projects make preservation a complex task. The question of how best to preserve these underwater caves for future generations is a thorny one. Do we close them off completely to avoid disturbance? Or do we document them as thoroughly as possible, using technologies like 3D modeling and non-invasive assessments, so that even if they're damaged, we retain a record of what was there? The discovery of the ancient human skeleton in the underwater cave provides an opportunity for public education about the importance of preserving our shared archaeological heritage. After all, these are not just the remains of a single individual. They are part of our collective story as a species. The discovery doesn't just tell us about our past, it also holds clues to our future. The skeleton, the cenotes, the artifacts, they all hint at the potential for more discoveries. As technology develops and research methods advance, we may find even more archaeological treasures. Who knows what secrets these underwater caves hold? Indeed, continued exploration and scientific research will deepen our understanding of our common human history. The ongoing work of archaeologists, cave divers, environmentalists, and others is vital in this journey of discovery. Their collective efforts will shape the future of underwater archaeology and conservation. As we wrap up this fascinating journey, we invite you to join the conversation. What are your thoughts on the discovery of these underwater skeletons? Please comment below and don't forget to like, share, and subscribe to Nautical Depths for more captivating content from the underwater world.